Good morning, everyone. A very warm welcome from Brussels. I'm Fabio Poretti. I'm the Technical and Scientific Officer at CEWEP, the Confederation of European Waste-to-Energy Plants, and I will be moderating today's webinar, which is organized in collaboration with ESWET, the European Association representing the suppliers of waste-to-energy technology. As you might know, today's webinar is hosted during the EU Green Week, and it will be focused on hydrogen innovation for waste-to-wheels solutions. We believe that strong synergies can be developed between hydrogen and waste-to-energy technologies. And today we will have 4 high-level speakers that will share with us the experience and their point of view. I see all of them connected on screen. So I will do a very quick roundtable for welcoming and introducing them to you. I see Ella Stengler, the Managing Director of CEWEP. Good morning, Ella.
Good morning, Fabio. Good morning, everybody.
Following Ella Stengler, we will have our first guest speaker, Jens Geier, who is a member of the European Parliament and the Rapporteur of the European Strategy for Hydrogen. Good morning, Mr. Geier.
Good morning to everybody.
Then we will further listen to the expertise of Pietro Caloprisco, Project Officer at the Fuel Cells and Hydrogen Joint Undertaking. Good morning, Mr. Caloprisco.
Good morning, Fabio, and good morning, everybody.
Great to see you. And finally, we will hear a study case from the industry with Andreas Meyer, who is the head of bus technology at the Wuppertal Waste-to-Wheels project. Good morning, Mr. Meyer.
Good morning, Fabio. Good morning to the audience. Hello.
Okay, so after the presentations, we will have a discussion and a Q&A moment where the participants can also interact in the event. Please write your questions in the chat. We will collect them and I will try to address them to our speakers during the discussion. With this, I think we can start with the opening remarks from Ella Stengler, the Managing Director of CEWEP. I see already your slides on screen, Ella, so the other speakers can turn off their webcams just for now. And great, so Ella, please, the floor is now yours.
Yes, thank you, Fabio. A warm welcome also from my side. As Fabio mentioned, this event today is jointly organized by us, CEWEP, and that's the Confederation of the Operators of Waste-to-Energy Plants, and ESWET, that's the organization of the suppliers of the waste-to-energy technology. We at CEWEP, we are the European Umbrella Association, and we represent the operators of waste-to-energy plants. When I refer to waste-to-energy plants or waste-to-energy, I mean the thermal treatment of residual household and similar commercial and industrial waste. That is the residual waste that remains despite all efforts of prevention, reuse, and recycling. So in other words, that's the waste that is not good enough for being reused or recycled. That is turned into energy by the waste-to-energy plants. And CEWEP represents more than 400 of those plants across Europe. ESWET is the Suppliers Association. They provide the technology, they foster the development and dissemination of waste-to-energy technology. ESWET has 28 members, including the main global players among the technology suppliers of the waste-to-energy sector. I will give you a very brief overview about waste-to-energy, what it is about, for those of you who might be not familiar with it. Actually, waste-to-energy has a double role in a sustainable waste management, hence the circular economy, as well as in energy production. So on the left side, you see the circular economy in the waste world. So waste-to-energy can contribute to sustainable waste management by diverting waste from landfills, which is following the waste hierarchy on the bottom of the hierarchy. So the waste that can be turned into energy does not have to be put on landfills. It helps quality recycling because it takes the residues from waste sorting and recycling facilities. So the rejects, which are not good enough for quality recycling, they can still be turned into energy by waste-to-energy plants. And last but not least, the main task of waste-to-energy plants is a hygienic one. So you need to deal with the pollutants embedded in the waste and avoid that they are spread in the circle. So this is the main task of waste-to-energy. It's a sanitary task. On the right side, you see the energy. So the plants produce as much energy as possible from the waste. And this is how they replace the use of fossil fuels to produce energy. And as part of the energy that is produced by waste-to-energy plants is renewable, coming from the biodegradable part of the waste, this contributes also to the renewable energy targets. Waste-to-energy plants are decentralized plants. They provide local and cost-effective energy, and they provide security of energy supply because they are base load. They operate 24 hours a day, 70 days a week. And so they provide a reliable source of energy on the local level. And the operators are looking into more and more into energy efficiency. And another aspect that we will discuss today is also energy storage with respect to hydrogen production. We will come to that later. Next slide, please. This shows the scheme of a waste-to-energy plant, how it works. On the left side, you see the waste delivery, the bunker. Then the orange part, that's the thermal treatment and the energy generation. And the part in blue, that's the flue gas cleaning. This is a huge part of the waste-to-energy plant. And this part guarantees the low emissions of a waste-to-energy plant. When I say low emissions, I refer this time not to greenhouse gas emissions, but to the pollutants like heavy metals, like dioxins. So this quite complex flue gas cleaning system is responsible to achieve very low emissions. And the waste to energy sector is covered by the most strict monitoring and emission levels, which it complies with. And that has been even updated in 2019 with the best available technology on waste incineration being updated. Next slide, please. Yeah, so to summarize, waste to energy helps to save millions of tons of greenhouse gas emissions. How does it do it? First of all, as I mentioned, it diverts waste from landfills, which emit methane. This is a very potent greenhouse gas. So the waste that is not put on landfills, but is instead treated in waste to energy plants, doesn't produce methane. Then waste to energy recovers metals and minerals from the bottom ash, which is the leftover after the incineration process. This also saves CO2 emissions. For example, aluminium can be recycled from the bottom ash and doesn't need to be doesn't need virgin materials. And last but not least, waste to energy substitutes fossil fuels in the energy production. About half of the waste treated in waste to energy plants is of biodegradable origin, and therefore the energy produced from this waste is renewable. All this is in line with the goals of the European Green Deal, and we feel very much at home in the circular economy and the Green Deal. Next slide, please. And that's my last one. So that brings me to the topic today. The waste to energy sector is looking into innovation. And when it comes to climate mitigation, that is apart from carbon capture and use, and if use is not possible, to storage of carbon, but it also looks into sector coupling. And there's a huge potential for synergies between waste to energy and hydrogen production. Waste to energy can rely on the programmability and also flexibility of the energy production. And this enables also energy storage with hydrogen production through an electrolyzer. We will hear more about it later on. Hydrogen projects are on the way in Europe. and they contribute to the production of green hydrogen through the electricity which is produced from the renewable fraction of the waste. And this helps to decarbonize the heavy transport, the tricky to decarbonize sectors like buses or waste trucks. It replaces the use of diesel, for instance. And it is important to produce hydrogen from residual waste treatment. This is recognized by the Environment Committee of the European Parliament in the European Strategy for Hydrogen. So what we need is a clear hydrogen classification system, and a reliable regulatory framework is necessary in order to provide investment. We will see today from Wuppertal, which is a good case, how they invested in order to produce hydrogen from waste to energy. And I imagine a lot of operators of waste to energy plants could follow this good example. But of course, it's a huge investment, and you need reliable policy and reliable framework to do that. So this is my very brief introduction to the topic. I wish you all a very interesting discussions, and yeah, enjoy.
Thank you, Ella. Thank you very much, Ella, for this opening overview on the sector. And we will now hear the opinion on the ongoing policy-making process on hydrogen legislation with Mr. Jens Geier. Mr. Geier is a member of the European Parliament for the group of the Progressive Alliance of the Socialists and Democrats, and he's also the head of the German delegation of the Socialists and Democrats. Mr. Geier is a member of the ITRE Committee on Industry, Research and Energy, and is the European Parliament's rapporteur for the European Strategy for Hydrogen. Mr. Geier, again, it's a pleasure to have you here today. Please, the floor is yours.
Yeah, thank you, Mr. Poretti, for giving me the floor. And I have to say, the rather complicated name of my political group is rarely spelled out completely as you did. Thank you for that. So the most to take the short form, the Social Democratic Group in the European Parliament. Yeah, I had the pleasure and the honor to produce the first statement of the European Parliament on that very interesting sector of hydrogen. What was done by a non-legislative initiative report. I have to underline that and a little bit to explain that, because the term might not be familiar to everyone in the audience, and it comes with certain limitations. So an initiative report is what we use in the European Parliament instead of the initiative right that the Parliament has. So it is an own proposal of the European Parliament in direction to the Commission, some, advice how we expect things to be done. Let me put it this way. But more important is that it has strict limitations when it comes to the volume of the report. So my first draft was limited to 5,000 words. So my very first draft had to be cut by 50% in order to meet the limitations. A lot of things were added by my shadow rapporteurs. These are the guys in other political groups who are responsible for that report, and I also had to amend my own report. I'm telling that just to explain that, of course, not all bases could be touched in this report. It is rather general, and the things will get more concrete when we now come to amending the concrete regulations of the Commission that are due in July on the energy and ETS sector, what will have the one way or the other a major impact on the hydrogen topic. So nevertheless, 5 points to 5 issues to carry away from that report. Firstly, the majority of the commission, of the committee, and also of the plenary agreed that at the end we want to have hydrogen made from renewable energy sources. So what we want to see is, nobody is doubting that hydrogen can be an important pillar in the decarbonization of the society, and that is due to the fact that hydrogen can be an important application in very different areas of the economy. I'm coming back to that a little bit later. So given that the majority agreed the hydrogen we want at the end will be the green one, that is the one made of renewable energy, acknowledging that in order to reach that, what makes a huge improvement in the sources of renewable energy necessary, we have to bridge the time with what is called the blue hydrogen. That is hydrogen made from decarbonized, from energy made from decarbonized natural gas. What is important for our topic today is that as long, and I'm coming to that also again a little bit later, as long as the waste source for energy that has been described in the statement of Ms. Stengler remains a renewable source, then the contribution is important. So in order to ramp up hydrogen technology, the plenary of the European Parliament is of the position that we should build up the technology where the demand is the highest. That is in industry. We also have a huge leverage in decarbonization of the industry when we look at, for example, first pilot projects that are to be done. My hometown is Essen in Germany, what is very close to Wuppertal. The project that will be shown to you later is well known to me, but I'm also politically responsible for the city of Duisburg, where the still biggest steel mill in Europe is located. And here the owner of that steel mill, what is ThyssenKrupp Steel, is trying to replace coke in the furnace by hydrogen, and they can bring down the CO2 emission of that furnace by about 2/3. So, I mean, that are really impressive figures to exploit low-hanging fruits in decarbonization immediately. And if everybody, and when everybody is talking about that, we do that while running out of time, I'm very much in favor that we go for this low-hanging fruit and that we exploit these potentials that are possible. So bringing hydrogen to the place where the industrial demand for it is the highest, that would be the second takeaway. The third one is, in order to do that, we need a market regulation, and we need it soon, because, or as fast as possible, because investors want to know what they get and what they invest, and consumers want to know what hydrogen they're exactly getting. So what we need is certification and standards. My proposal would be that we go along the CO2 footprint of the hydrogen, and here comes a little bit a dangerous situation for the waste industry, because what we know from the plans of the Commission right now is that it is not sure in the moment whether the renewable standard will be in a way that electricity from burnt waste is still counted as renewable. My personal opinion is still that it is, and I would do a lot to defend this quite successful business case. So bringing the infrastructure to life would be the fourth important takeaway from the report. Of course, we can only build up a hydrogen technology all over Europe, and we have the infrastructure to do so in terms of electrolyzers, but also in terms of pipelines. And the last one would be that nobody, or not so many people in the European Parliament, believe that the European Union becomes self-sufficient in energy terms. So we will have to import. We will continue to have to import energy from abroad, from outside the EU. Of course, we have to exploit everything what is possible in building up renewable energy sources inside the EU, but I'm very much in favor of building up coalitions in the European neighborhood, and I'm especially thinking of the North African countries here, to provide a sufficient production of hydrogen that can be used in Europe. So these are basically the 5 takeaways from the report, quite general, and we are now expecting the Fit for 55 package, as it is called, from the Commission in July. The 14th of July is the day where the Commission has the publication announced for all that, and then we will come to the concrete regulations that will pave the way, so I hope, for a quite successful way of using hydrogen in the European Union. Thank you for listening.
Thank you. Thank you very much, Mr. Geier, also for the insights on the recent report of the European Parliament. We'll now move to Mr. Pietro Caloprisco. Mr. Caloprisco is a project officer at the Fuel Cells and Hydrogen Joint Undertaking, where he's following the portfolio of projects dedicated to the development of fuel cells applications for the road heavy-duty transport segment. Previously, Pietro worked at the European Commission DG for Research and Innovation, where he specialized in alternative fuels for the decarbonization of the transport sector. Mr. Caloprisco, it's a pleasure to have you here today. I see your slides on screen. Please, the floor is yours.
Thank you very much, Fabio, and thank you once again for also inviting the joint undertaking to take part in this interesting event. Ladies and gentlemen, welcome again, also from my side. Good morning. With my presentation, it will be fairly short. We don't have so much time, but I will try to a little bit frame the discussion to give you the point of view of what we are doing with the fuel cells and the joint undertaking, who we are, what are our activities and achievements, and then focus a little bit more on the issue that is at hand today, so the waste-to-wheel business model, and what are the possible synergies that we see from our side. So first of all, I already see the first slide, the short introduction to our outfit. So the joint undertaking is a public-private partnership. The public sector is represented by the European Commission, different DGs are involved, while the private segment is organized in 2 different groupings, in the industry and the research grouping, which are organized by the Hydrogen Europe. Together, they form the governance of our organization, and they define how the funds that are dedicated to the development and deployment of fuel cells applications should be spent. Over the last 2 joint undertakings, we already had 2 other joint undertakings under the FP7 Horizon 2020, and now the next joint undertaking under Horizon Europe is under discussion. But so over the last 2 periods, we have already supported 285 projects for a total budget of around 2 billion. Half of that budget was coming from public sources, and the other half was obviously matched by the private sector. If we look at how these funds are distributed, you can see on the right-hand side of the slide, there are 2 main pillars that absorb these funds. The first one is what we call the energy pillar. This is dedicated to the production and stationary applications, so the production of hydrogen and stationary applications. Then we have the other large pillar, which is dedicated to transport, all transport modes, as we will see later. And then we have 2 additional pillars for the cross-cutting and overarching topics, so issues that are of interest to all the fuel cells and hydrogen applications. The next slide, please. So all of these projects are, you have to consider them as parts of a big puzzle, and this graphic represents the puzzle that we are trying to realize, and that it was also mentioned earlier. So we are looking at the development of technologies for the production, storage, and distribution of hydrogen, all the way to its consumption in transport or stationary applications. And I think that this is also an important, this is just a picture scheme, but it highlights how pervasive, how flexible is the use of hydrogen, and how it will become more and more interesting. It is not only a technology, a solution that can help you to decarbonize this or that sector, but will also help to create the coupling, which, given the ambition of the Green Deal by 2030 and 2050, it will be an increasing important element of our strategy. I mean, the coupling of different sectors. And next slide, please. I just wanted to give you now a quick overview of the technology, so the achievements, what we have achieved so far, and what you can expect in the future. So again, this will help us a little bit to give us the framework for this waste to wheel concept. So still less than a decade ago, when we are looking at the electrolyzer, the capacity was well below 1 megawatt. And this public support that we had to provide in order to make this technology and business cases fly was quite considerable. However, keeping a lot of details and evolutions and projects, we arrive at where we are today. Only September of last year, there was the Green Deal call, which is calling for the development and deployment of 100 megawatt electrolyzer. So I think that just using this KPI, this key performance indicator, just looking at the capacities of what the electrolyzer can do, it already gives you a quite idea of how the technology has evolved and what we can expect for the future. Now, much remains to be done, of course. We are not quite there yet in terms of costs, performance, and so on. However, you could say that at least from a technical point of view, we are on the right trajectory to contribute and realize what is the green, the hydrogen strategy goal, which is to have 40 gigawatt of electrolyzer installed in Europe by 2030 using renewable electricity. The next slide, please. So this was just a quick overview of some of the key achievements on the energy pillar. Now we are looking at what we have been doing on the transport side. So also in this case, our program is starting with the development of the single components. So I'm talking at the fuel cell level, bipolar plates, stack, tanks, all these things that are for people that are really working to the sector. But so these components, they have over the years decreased their cost while increased their performance. What does it mean? Well, in real life, it means that in the past we had projects and commercial applications which were limited to light-duty vehicles, private cars, material handling vehicles, or buses. So all transport applications that either didn't require a lot of hydrogen or didn't require a lot of power. But as the technology is progressing, as you can see now, we are moving to heavy-duty applications such as trucks that for the collection of garbage, long-haul trucks, trade, aviation, and maritime applications. So this is a very fortunate, let's say, development of the technology, because it matches also what are our legal requirements. As you know, transport will have to decrease its CO2 emissions by 90% by 2050. So all transport modes will have to contribute to this effort. So the deployment of zero emission vehicles, such as fuel cell based vehicles, will be key into that sense. Then, of course, we are stepping up our production. We have more performing components for transport applications, but we also need something that will bring the two things together. And I'm referring here to the infrastructure. Of course, we will need to have a lot of refueling points in the future, many more than what we have today. But this refueling station will have to be also up to the task, more performing for these new transport modes. So in the past, you had light duty vehicles that would take only 5 kilos of hydrogen, and they could be refueled in 3 to 5 times. But now we are going to these commercial applications like long-haul trucks that in one go can take 70 kilos of hydrogen. So you understand that the size of our hydrogen refueling station has to increase the capacity, but also the flow rates. So we also need to recharge these vehicles very quickly, because they cannot simply sit around waiting to be refueled or recharged. So with these two slides, I just wanted really to give you a quick idea, without going to the details, of what the technology has achieved and in which direction we are going. If we can move then to the next slide, I want to go closer now to what is the topic of today by speaking about the project Revive. Here you can see, the key figures about this project. This is one of our typical demonstration projects. So to showcase the technology, to monitor it, to see what is the performance. What this project intends to do is to indeed validate the use of fuel cells trucks for the collection of urban waste. We will deploy 15 trucks in 9 different cities across 4 countries. And these trucks will be operated in real life conditions, so no special treatment for them. They will be operated by waste collector operators that will test these trucks against what they are using now, the incumbent technology, which is diesel. So if you wish, well, it's an important project, but it's a classical project in the sense that really the idea here is to deploy the technology and to test, to see, to monitor it and collect the data to see where we still need to do the research and to see also where the things are already working fine. If we can move to the next slide now, there is an additional interesting component though in this project, which is the waste to wheel study. So in addition to testing the vehicles, the consortium, which involves OEMs, cities, waste operators, will also carry on a study which has really the scope to identify under which condition the business model, which is based on the vehicles based on fuel cells on one side and the production of hydrogen coming from renewable sources, which is coming from the waste valorization, could work. So the idea is to create this closed loop where the trucks are collecting the garbage, which then in part will be used for the production of the hydrogen that they need to operate. And in particular, the study will focus on defining under which circumstances this pathway of producing hydrogen is interesting, is more competitive than other pathways for producing hydrogen. Of course, it will then assess also the performance of the trucks. And at the end of the day, what it intends to provide is a techno-economic assessment of the whole package, of the whole idea, the concept. On one hand, the value of this study is really to raise awareness about this concept, but on the other, it really wants to provide a blueprint, an example that other cities that are interested in this idea could try to replicate in the future. So unfortunately, I'm not in the position to share the result of the study just yet, because we are still in the phase where we are deploying the trucks of the Revive project. 3 trucks have been deployed so far. I can only invite you to stay tuned for these results in the future. Here, maybe I can also say that there is a high interest on this concept because it's as it has been said also earlier during the introduction, it's very synergetic, the concept of waste wheel and the hydrogen production. It can bring several benefits for all the actors that are involved. Local authorities, they will avoid landfill, they will also increase the use of zero-emission vehicles. If there is a production of hydrogen when the supply of renewable electricity from waste valorization is higher than the demand at that moment, well, that's when you can produce cheap, let's say, hydrogen. And this will contribute to also close the price gap between the diesel trucks and the hydrogen trucks. Then also OEM will find it interesting that this may be what could be called a niche segment for them. This type of vocational trucks will also help them, the sales of these trucks, to achieve the targets that have been set out by the regulation for the CO2 standards for heavy-duty vehicles. These are just some of the benefits that we see for this business model if it was to emerge and to be replicated in several cities across Europe. And with my next slide, I would like just to conclude this very generic, general overview by also highlighting the fact that Revive is not the only European project that is dealing with this topic. There are two additional projects that are mentioned here, Life, Graben High and Hector. And these three projects, they also signed an agreement that will allow them to cooperate, not only to raise awareness about these business models, but also to gather and discuss together their respective experiences so that they can come out with a coordinated set of policy recommendations that will help the waste wheel concept to emerge strong in Europe. So I'm afraid that this the time is up for me, and this is all I wanted to share with you, and then I'm looking forward for the discussion that we will have later. Thank you for your attention.
Thank you, and thank you, Mr. Caloprisco, for these fascinating possibilities on hydrogen developments in waste-to-wheel solutions. Now, to conclude the presentation from our guest speakers, let's hear the experience on the field with Mr. Andreas Meyer. Mr. Meyer is the head of bus technology on the Wuppertal Waste-to-Wheels project. And he also collaborates actually with the fuel cells and hydrogen joint undertaking for the market activation of fuel cell buses. He has many years of experience in vehicles management and in the hybridization and electrification of vehicles with different application ranges. Mr. Myers, I am very, very glad to see you again today in this occasion. Please, the floor is yours.
Yes, thank you, Fabio, and second hello from Wuppertal to the audience. I'm happy to give you some information about the project H2W, Hydrogen Mobility for Wuppertal, that is first based on operate 10 buses. And the second step is now that we have since Saturday a waste collector as a second step, and yes, later on more to this point. Further on, I want to give you some information about our company. We are a local utility. The special thing is that we have all sectors under one roof in this utility. That means that there's a mobility, there's the energy and waste sectors too. And so that was also a nice thing that we can realize this project, that we have all these sectors under one roof and we have good connections to each other and realize such a project like we have done. Next slide, please. So yes, 6 years ago, there was a mindset from our company that we discussed that we have both the energy sector and the transport sector. We are in the same situation, that it was said that we have to reduce carbons, and in the energy sector also it was clear that we have to step out from the conventional power generation, especially the coal. And we have to save carbons in the whole network. And so it was necessary, when we want to do it, that we have flexibility in all our network. At the other hand, there was the transport industry, where we have stricter environmental requirements. The Clean Vehicle Directive was growing up, and now at the 2nd of August it will be run. So there was requirements that we have to realize or we have to look at. And so the way to e-mobility was set, and yes, both things are also a kind of necessity to have flexibility also in the refueling of in the transport sector. Next slide, please. Yes, and when we start to think about electric vehicles, both possibilities, at one hand the batteries, at the other hand the fuel cell was we take a look at. And yes, to give you the information about Wuppertal, Wuppertal is an yes, middle city in Germany, but it's a very hilly area, and they forgot to bring at the passes to the hills. They forgot to have turnarounds, and so it's very difficult with two yes percentage uphills. So it's necessary that we have we check that we need 1.7 kilowatt hours per kilometers in our topography, which requires, if we have a look at batteries, a large battery to achieve the operating ranges. Yes, we have reduced storage within batteries, it's clear, and so we thought that it's not the right solution for Wuppertal. And then we look at the hydrogen fuel cells, and there we identify that we have flexibility that I talked about before. We need this in the storage. We have a better performance, or the same performance for operations like with diesel buses, and we have a fast refueling nearest to 10 minutes with this vehicles, bus vehicles. I talk about buses with a high volume, 35 kilograms per bus. So the fast refueling was also set by us because we want to change our operation skills, and so it was a big advantage to use fuel cells, and we make the decisions to use them and bring electricity vehicles in this form on the streets. Next slide, please. Yes, we check a lot of things. Also, the one important thing is that we have an economic project, and therefore we have to check what are the costs from hydrogen at the market. At that time, when we decide to make a fully integrated project in our company, the price from hydrogen was too high at the market for us. So the decision was made to produce on-site in our company to reduce costs at all. And so at least we have the system that we take the waste to energy plant, where we produce energy too, as also heat too, but also energy. Use this energy to bring it on the spot market or to the electrolyzer. This is managed by our energy and water company. They had lines from the energy prices, so it's a cheaper periods. We use them to the electrolyzer, and yes, from there to the storage, to the hydrogen HRS, to the bus, to the wheel. So we have a really ongoing process from the production of energy up to the wheel of the buses. Next slide, please. Yes, our energy plant, waste to energy plant, is still up here. We have at the moment 5 boilers in operation. Depending on the waste supply, on the waste chain, we use 3 up to 4 boilers in the moment. From these boilers, yes, we have, I tell it that we have two turbines over that we produce power, and at the other hand we use it for the CHP, steam, and water heating from our city. So, but for us, it's interesting that we go with the power to the spot market, or like here to the hydrogen production. Yes, next slide, please. Yes, in a short overview, we have the energy generation with 50% renewables in the waste. So we have 50% renewable energy from our plant, and this, or parts from this 50% renewables, used for the electrolyzer, going to the storage and to the bus. With this, we have 1 megawatt electrolyzer implemented here in this plant. That is, yes, we have enough hydrogen in an optimized system to supply this for approximately 30 buses. Yes, we have also demineralized water in the plant, so we can use this for the electrolyzer. It's an upside that makes it a little bit cheaper. Also, I mentioned this, that we have 50% renewables, and at least that is not done now, but in forecast, what we want to optimize in the next future is that we use the oxygen and the heat from the process of the electrolyzer to use it for other cases. Next slide, please. Yes, the approach from hydrogen, technically in public transport, but in transport sector at all, is that we have, or that we see some advantages. I will concentrate to the second and third bullet points here, that it is possible with hydrogen to decouple the refueling from the energy use. That is very important when you have when you want to realize an economic system, because we see that the energy prices are growing up with more renewals in the net, and so that has a significant influence, the decoupling from the electric energy prices for the mobility. That was the most interesting bullet points are for us, that we can this realize, and it will later on show you what effects this have to the hydrogen price and to the energy price. Next slide, please. Yes, before I came to this items, I will show that we have an, yes, the project includes that we first at all think about the energy use, depending on the topography of the interval length from the buses, from the logistics, and all these items we bring into a tool where we can calculate the input of these things. At the end of this, we find a refueling strategy to refuel the buses, later on also the waste collectors. And with this knowledge, we can decide what is the dimension of the electrolyzer, how is the dimension of the storage, and to optimize the system, because at the end of the day, it's very important to, because the capex is here dominated, the cost of the hydrogen, that we find a good solution, customized or a tailor-made solution to have an, yes, nearly really good hydrogen price, nearly to the diesel cost at the moment. Next slide, please. Yes, that is the effects that we additional find that we and what I mentioned before. At the right figure, you can see in the blue color is the hydrogen storage. The red line is the energy price at the stock market, and we bring the or we will produce hydrogen in the lower price areas, so that it makes sense to do it, because at the left side you see the effects of that. The blue line at the left side, that is when we use the electrolyzer 3000 hours. It brings flexibility in the production of hydrogen. In the moment, we have only 10 euros per megawatt hours in the flexibility to the red line, because this is the line from 6000 hours usage of the electrolyzer. Yes, but it will increase up to 2030. That's the right side of the left figure. In 2030, we have more renewables. We have other peaks in the energy costs day ahead. So there, it makes sense to have the flexibility, because the spread from 3 to 6,000 hours is going up to have a bigger interest for us. And so it makes sense to have this calculation before you start it, because every time again we want to have an economic system that makes sense, not only an environmental vision of this. Next slide, please. Yes, at least you will see here that we have a base cost from the investment and the flexibility costs from the energy. You see in the moment in 2019, when we start operation, we have an approximately price on 6 hours of the hydrogen per kilogram, and it will increase over the years with more renewables, with higher energy prices to 9 euros per kilogram. But in comparisons to this, the black line is the diesel price. Here is the diesel price with 25 euros for carbon taxes, but it will, and I'm sure that it will increase more than here is shown in the future. I expect that we have when we have the election in the latest in the year, that we have another diesel line with more carbon taxes, and so maybe, or not maybe, I'm sure we are also with 9 euro per kilogram hydrogen price for our on-site production. We are under the diesel price in the future, and so we can a little bit came nearer with the TCO from the vehicles to the equivalent of a diesel bus. So that was in short what our project. We are happy to operate the buses that are shown here, 5 from 10 buses from Van Hool. It's in Belgium OEM. Yes, I think we have a good project. We are happy. The buses will run in operation perfect. The hydrogen production with all things we can realize here at the waste energy plant are also running well. Honestly, we have with this new system sure that there are some problems, but we can solve all these problems in a natural or normal way. And so this vehicles on the road, and we are happy with them. And in the next slide, you see the first waste collector truck that is delivered on last Saturday, and we are starting operation, I think, in the next days when we have, prepared some other things. So at least, yes, a very successful project was that we can show that it will run, that we have no big problems. It's a standard solution that a blueprint for other companies who want to do the same thing in this area, in their areas. Yes, and that was it from my side. Thank you very much.
Thank you, Mr. Meyer, for showing us what's going on at the Wuppertal waste-to-energy plant, and many congratulations for this pioneering project in this hydrogen adventure. So this concludes our set of presentations. We will now have approximately 30-40 minutes for our discussion. I would then ask all our guest speakers to turn on their webcams again. So we received different questions, I would say, in the chat during your presentations, and I apologize if we won't be able to touch all of them today for time reasons. But I would start with the consideration that we actually already touched on hydrogen capacity development, as also the importance of producing hydrogen from residual waste treatment facilities has been recognized as well in the opinion of the Environmental Committee of the European Parliament on the hydrogen strategy. So, keeping the same order of the presentations, I would like to ask to all our guest speakers, what potential do you see in the future for the production of renewable hydrogen from waste to energy technologies? Mr. Geier, if you would like to open the discussion, please.
Yeah, thank you. As I pointed out, that is the hydrogen from renewable sources is what we want to achieve finally. And that makes it necessary that we, of course, use all the sources that are given. I expect that the revision of the Renewable Electricity Directive that is also due in July will pave the way to more green energy all over Europe. And I personally would like to see that there are binding targets of increasing the green energies all over the member states. Mr. Meyer and myself, we're coming from Germany. We know that renewables in Germany has been developed in the last 15 years quite nicely, but there are a lot of other EU member states with a huge potential lacking behind. So this is the general picture. And in order to have the green hydrogen that we want, we have to use all the sources that are given, and waste industry is one of them. And I think the business case presented from Mr. Meyer from Wuppertal is an excellent example how it could work. And I would like to see this as a role model done all over Europe. So there seems to be a huge potential, and I'm very much in favor of exploiting that.
Thank you. Mr. Caloprisco?
Yes, well, I think that I would concur with what Mr. Geier already said. I think that it's clear in which direction we want and we need to go. I mean, hydrogen only makes sense if it's here to reduce CO2 emissions. I mean, the fact that they will reduce pollutants, local pollution, it's already a given, it's clear. But then the big focus is upstream. What are the different pathways which are available for the production of hydrogen? We all know that there is already photovoltaics, wind. The capacity is increasing on daily basis. In some areas, there are also issues with the grid. So how much the grid can absorb of this, some people call it intermittent. I prefer the term variable sources, renewable sources. And in that case, really the hydrogen can come into play as a solution to balance the grid, and we can use it to also, of course, then this hydrogen for transport and different applications. Now, when it comes to the waste to energy, as we heard also today from Mr. Meyer, this is a very interesting concept, and when it works, it can also deliver you very affordable hydrogen that eventually will make the whole TCO of your fleet of vehicles more interesting. Now, when it comes to the potential, though, I'm not quite clear. It will always depend on what is the availability of this waste in Europe. And also, there will be a lot of local considerations that I think will come into play. Because, of course, when you're able to create these closed loops, let's say almost islands, no? Where you have a system, the production of hydrogen that is locally consumed by captive fleet, This can also simplify the whole hydrogen logistics, the delivery of hydrogen, be that via tube trailers, trucks, or the pipelines, which the system is not there yet. So I think to give a clear answer on what is the potential, we really need to see what is the availability of waste and in how many local situations then this business model will actually make sense. Right now, I see it as a promising concept. I wouldn't be able to guess though in percentage versus other renewable sources how much it will be this way that the hydrogen would be produced. But definitely an interesting concept, I would say, that we'll keep one eye on it.
Thank you. Mr. Meyer?
Yes, in our opinion, it's really necessary to use waste energy plants to have this as a backbone for green hydrogen at the local production, because we know all, if we take wind power or photovoltaic power, it's only available, yes, on-site maximum 2,500, maximum 3,000 hours a year. And with a waste to energy plant, we have a backbone with, yes, allowed 6,000 hours in the future. I think so it will be done, so that we have really a production from hydrogen at a good range of time where we can realize it. And it's also very necessary in the future. Sometimes we look at the future in 20 years or in 15 years, and we have Algeria or something with big pipelines and it green and all these things. But this is a long time, and we want to increase now. And when we want to increase now, we need local solutions to increase the renewables, to use them to produce hydrogen as a storage energy. And so therefore, waste to energy plants are very necessary, and we are happy if it's the rules in future bring us also a solution that we can about green or maybe orange. I don't know exactly. It's so many colors in the moment. But yes, it's for us a very base scenario that we need to invest also in the vehicles.
Okay, thank you. Thank you all for your opinion, and always related to this topic on hydrogen development. Another crucial aspect that emerged from the report of the European Parliament is the ramping up of hydrogen production to reach the desired targets. What financial tools or solutions do you think that will be key to develop the market uptake of renewable hydrogen and make it fully mature? And I use this question to combine it with another one. What role can some European programs, such as the Horizon Europe, the Invest EU, and the Innovation Fund, can play to help financing clean hydrogen projects also within the waste to energy sector? I think, Mr. Geier, we can start again from you if you would like.
Yeah. Well, depends. So Horizon, of course, is a research program that can finance also pilot projects for industrial application, but this is not the tool for the broad investment. Of course, research and development is necessary all along the value chain of hydrogen, and when you really start to delve inside the subject, you see some engineering progress almost every week. What is good, because at the end it makes hydrogen, the production of hydrogen, cheaper because more effective. So that can be done with Horizon. You rightly mentioned other instruments, the investment fund, the Invest EU tool, several instruments provided by the European Investment Bank. And one thing that is necessarily to mention here when we have a European audience, of course, is the Reconstruction and Resilience Instrument Fund. I mean, we mobilized 750 billion euros to get European economy out of the Corona crisis. That has to be spent in the next 3-4 years. So this is a one in a lifetime opportunity to overhaul the energy production, the grid, to support renewable energy investments in the European countries. I mean, at the end, it is the responsibility of the membership of the member states how the money is spent. But it needs some pressure from the civic society, also from the Commission, from the European Parliament, that this money is spent wisely and in order to reach the investment, the political goals of the European Union. Finally, there is a lot of money in the financial market to be invested in sustainable projects. So money for investment, the capex seems not really to be the problem. Rather, to me, it is the OPEX, because as long as hydrogen is too expensive, we have to pay we have to draw political consequences out of that, and that is something where we have to give a thought on supporting OPEX costs. Thank you.
Thank you, Mr. Caloprisco.
Yes, well, indeed, I would say that the game is changing. In the last, under the last 20 years or so, or like let's limit it to the last 2 framework programs, I think that there was a bit of a one-stop shop when it was about the deployment and the development of hydrogen technology. That was the 2 joint undertakings. However, the technology has progressed. Again, as we said earlier, the decarbonization goals are being increased. So we need to really ramp up, and we need to feel now the impact of these technologies. We need to deploy them now. And in that sense, indeed, also a lot of what the joint undertaking was doing in the past, maybe now we need to be complemented with other funds. So some were already mentioned, like for example, the innovation funds, and also I think they are very interesting, the important projects of common European interest, the IPCI, I think is the pronunciation. So these are definitely funds that we need to exploit, and they will be important because we need to reach a large number of units that needs to be deployed on our roads, on our streets, be that or stationary application to increase the production, or also the number of vehicles. And it was, as it was rightly pointed, so the joint undertaking, we are at the end an expression of the Horizon Europe or the Horizon 2020. So we can arrive up to a certain level. We are really pushing the technology to the higher TRL possible, but then after that we can still at the maximum go to maybe we will see in the future hundreds of units, but here we are talking about thousands, hundreds of thousands of units, and the technology indeed will need these funds that will decrease the initial capex and the perceived technical risks. So just going along with the private investment, maybe we are not there yet, or we at least need to accelerate these dynamics. So, and then maybe it's also worthwhile to when we're still talking about the funding of the technology, to highlight that in addition to the joint undertaking, in the future there will be, under the new Horizon Europe, a number of other partnerships that will start to deal with hydrogen. Just to mention some on transport, we have the 2.0 partnership, the Waterborne, the Shift2Rail, Clean Sky. So these are all partnerships that are dedicated to specific transport modes, and they are developing vehicles in that area. But given the importance that hydrogen has now, they will also start to cooperate with us, and we will cooperate with them with even at our TRL level to ensure the uptake of the technology.
Thank you. Mr. Meyer.
Yes, further all, what I forgot to mention is that the project in Wuppertal wasn't able to realize if there's no funding on one hand from the CHU with a market activating program, but other funding too from local and from German country. So at least funding is, I have to separate, and I'm happy that Mr. Geier, that the politics recognize that the OPEX is a problem, that we have to, there are so many projects around this, yes, electrolyzer vehicle. We have to digitalization some things, we have to change operating systems. There's also, that brings in a lot of economic problems. And that can't you show in one chart, or it's a lot you have to do, and that will cost money. So so OPEX is a really big item. On the other hand, when we look at the CAPEX, I'm not sure if I'm happy or I'm not so happy about the funding, because funding is not an instrument for the next 20 years. Sometimes funding is out of the system, and now what we see that the OEMs will set their calculations and the price, including the funding. And when we set this price for the future and this level, we get a problem to operate or to realize this CAPEX after funding is going out of the market. So yes, in the moment we can't realize such projects like in Wuppertal without funding, but we have to see what's the best version of funding is, and I'm with you, Mr. Geier, that OPEX funding and funding that makes it realistic to change technology from diesel to hydrogen with our own plant to produce hydrogen. That is yes, that we find another systematic in the funding potential.
Thank you all again. I would take, so this consideration that we just had on financial aspect, to say with you, Mr. Meyer, to take advantage of your experience at Wuppertal, but I also ask, say to Mr. Geier and Mr. Caloprisco to jump in if they would like to. Could you please repeat, Mr. Meyer, what is the price of hydrogen that you're having now, if you also consider it before and after compression at the nozzle?
Yes, before and after, we have our calculation, it's a nozzle at all. So we started, it depends on the energy price on the market, because the optimization of the system is that we go to the lower level of prices when we produce, that it's not every time the same price, but it depends on how much wind is in the net and such things. But it is between 5 and 6 euros at the nozzle in the moment. That's yes, when we start the project, it was much cheaper than available in the market. Now we see companies that bid us in the same level, but at least that's the price. But it will increase with higher energy costs. You know that we need approximately 60 kilowatt hours per kilogram to produce hydrogen. And with increasing energy costs, we have increasing prices, so it will grow up in 2030 in our calculations to 9 euro. But every time what we have to check is, how is the diesel price? Can we under the line of the diesel price, or is it higher? The mobility cost, I think it's maybe on the same level with the diesel level in the future. So only the production from hydrogen, when we go with electrolyzer, with the 30 bar output from hydrogen from the electrolyzer, it will be on a level from approximately 3 to 4 euro.
Perfect. That's great to hear. Staying on this, the diesel that you mentioned, what is the relationship between savings on diesel costs for buses and the losses on the sale of electricity to the grid? Do you maybe have a figure for that?
Yes, I have no figure for that. I have an idea. I think so. That's the possibility to we calculate opportunity costs to the grid. That is what we have a special contract in our subsidiary in the holding, and that is very complex. But at least we have the costs when only that we have to produce hydrogen are lower. But with the opportunity cost to the spot market to calculate the hydrogen, then we came to the level I talk about. The spread between both things, maybe it's 1.5 euro.
Okay. Okay. Another consideration that was raised in the chat about CapEx that we also mentioned, as you know, we say CapEx as the dominating factor in the cost. It's very relevant. Which part of the project CAP is dominating? Buses, electrolyzer, or the storage and filling facility?
Okay. In this calculation, when I said CapEx is dominated, it's only the production of hydrogen. The buses, we have double costs, or three-time costs in a hydrogen bus in comparison to a diesel bus. So without funding, no possibility to realize it. In the hydrogen production, there's the dominating capex cost, because when you have the problem is you have to match the usage of the hydrogen with the production of the hydrogen. If you have an 1 megawatt electrolyzer and only use it for 10 buses, you have, I mentioned, it's 3,000 maximum 3,000 hours. And so the downtimes of the electrolyzer is or the production line of the electrolyzer is so low that you can't have a good economic item. So you have to bring it up to 6,000 euros, where the capex is bringing to the whole total price of the hydrogen, and then it makes sense. So nearly 100% capacity of the electrolyzer to use it, to bring it in the user's cars, vehicles, that makes sense, and you get a good price level. When you have an electrolyzer is in the moment too big for the usage of the operators, then it is extremely expensive.
Okay, thanks. Thank you for this insight. Very interesting. And staying on this,
Fabio,
go ahead.
What we do in North Rhine-Westphalia is a part of Germany. We want to solve these problems, and that we will talk about an enabler, and that we want to start with a company that collect all the hydrogen that is produced at the waste to energy plants over the levels they use for their own companies, to bring it in one company and spread it out to the companies who has no own on-site production, and give it to them for the best price we can realize. So it's an ecosystem in North Rhine-Westphalia to bring it to the level that the electrolyzers have a high production rate and reduce the price of hydrogen.
Okay, I see, Steve. Thanks for this integration. Staying always on this market consideration, I may have a question for Mr. Caloprisco, because when it comes to using hydrogen as transportation fuel, what is the most ideal market and why? Road transportation, aviation fuels, or shipping?
Well, that's a good question. I mean, on one hand, there is the need for decarbonizing these transport modes, and what are the alternatives that we have there. And then on the other hand, we have to match this with the technology readiness, so what we can offer in terms of components. Now, I think if we look in the medium short term, where we see the biggest market is really the heavy duty road applications. We have there components that had gathered, let's say, millions of kilometers of experience in the past in different types of vehicles, light duty vehicles, which have different requirements and different cycles. However, we have gained a lot of insight, on each one of the components, how they are performing, how they are aging, the type of power output that they can give us, and so on and so forth. So the closest experience now ahead of us is the road heavy-duty applications. And as I said earlier, this is also quite timely because you know that recently there was the new regulation for the heavy-duty sectors that until now was not really under a lot of pressure to decarbonize. And what we hear from the OEM is that by 2025, they can reach the targets with still a modest deployment of zero emission vehicles, be that battery for the short range or fuel cells for the longer range. But when it comes to 2030, it starts to become extremely difficult for them just by improving the combustion engine thermodynamics to reach those targets. So a considerable amount of fuel cells trucks will have to be sold and deployed. Just last year, we have done a study to look into that, to see what is the TCO of the heavy-duty vehicles compared to diesel, and we saw that by 2030, there is a strong case for the fuel cells because they can become cheaper than diesel, and of course, and also cheaper than other alternative decarbonization alternatives, be that pure battery vehicles or catenary. Of course, then this study then also needs to be deployed into the, let's say, reality, and we have to see on the different use cases that are out there, under which circumstances we can realize this fuel cell shift. But I would say in general, definitely it's road transport, it's heavy duty, it's where we see the next application, while we are gearing up also for aviation and maritime application. The maritime, in this case, we are mostly referring to products, stationary products that will have to be adapted for this type of use. And when it comes to the aviation, maybe it's the sector, it's the transport mode where currently right now we are lagging behind a little bit. We are starting with the small planes, but definitely I think that also there, if we want also to realize the ambitions of the ICAO by 2050, the technology will have to deploy to a certain extent. By 2030, we will have to start with at least with the small flights in Europe to be operational. So I would say in general, yes, as I mentioned at the beginning, really the technology is performing enough that will allow us to deploy it in all these new transport modes.
Thank you. Thank you, Mr. Caloprisco. Maybe, Mr. Meyer, I come back to you. I don't know if this could be a more technical question, but sometimes it is claimed that the hydrogen production from electrolyzers is not efficient due to the overall energy conversion losses. Could you please clarify maybe this concept, please?
Okay, so I love this question because that's the efficiency of the system is yes. I came from the combustion technology. I did a lot of hours to check if it is 40 or 45% efficiency and combustion engine, but that's not the problem today. The thing is today, what is in the net available? How many green energy is available, and how can I use it? And when I have in the grid so much necessities to use energy, and I can't realize it, then it doesn't. It's not a question of efficiency of one system. You have to think it in a whole system, grid. System, bus, waste collector, truck, and so in this combination, I think that is what we have to look at. What is available and in green power in the net in total, and what can you use, and then we can decide if it's the efficiency is good or is bad. Not only if we have battery buses more efficiency than a hydrogen truck or something like this. It's not the question today, in my opinion.
Thank you. Okay, maybe a very last question for you, Mr. Meyer. You know, Mr. Caloprisco also showed a very nice picture on the importance of sector coupling and energy system integration. So I would ask you, at the Wuppertal waste-to-energy plant, is there the possibility to recover the unavoidable excess heat from hydrogen production from the electrolyzer, maybe for heat purposes or for the district heating network?
Yes, that's our plan. There's a little bit of temperature difference, so we have to an additional heat it up for the system at all. But it's possible. We check this as an upside that we want to realize, and also what we realize in the nearest future is the oxygen that we bring it to an water. Yes. Yes, to make the water cleaner. I don't know, there's a special word for this plant. That is what that we want to realize in the next future. Both is an upside that is possible, and therefore, yes, efficiency is growing up.
Okay, thank you again. So as we are approaching towards the end, I would like to dedicate this remaining minutes for a very last roundtable with all our guest speakers, asking them what would be your key messages and the final takeaways from today's webinar. We can keep, again, the same order, please, Mr. Geier, if you can start.
Yeah. Let's have a European market order that supports green hydrogen and does not discriminate the blue one in order to ramp up the technology fast and bring down the prices. So that would be my most important message.
Thank you.
I think I will follow up also by highlighting the urgency. I think that now is the time that we have to say, are we just talking or are we serious about the targets that we established by 2030 and 2050? Because if we are serious, we are already late. All these transport modes needs to be decarbonized now, not tomorrow, now, really. Look at the lifetime of just a truck, for example, it's 10, 15 years. If we want to get somewhere in 2030, the planes and the boats is even worse. So with this technology, they really needs to be deployed as fast as we can. And at the same time, I think we also have to embrace complexity. Let's try to avoid the narrative of the silver bullet. Yesterday, we wanted to do everything with biofuels. Now there are also those that advocates that battery is the only way to go. No, each transport mode has a slightly different story. We need to optimize how we want to decarbonize the transport system, but we also have to accept that there are different requirements, different technologies, and we have to exploit them all. And we have to explore concepts such as waste to wheel that can really bring the competitiveness also from the economical point of view of the different technologies on the table.
Mr. Meyer.
Yes, yeah, short. Our aim was to show that it is possible to combine sectors, and it is very efficiency. So we show it, and we want to go on, and we have to. Yes, I can repeat what the other said. We have to go on now, not wait and see what happened. And when we have shown this, we have to make a little bit pressure on the vehicle OEMs that they will can take the speed that we do in our project to deliver vehicles that we need in this process. It's very important. So that yes, that's it.
Okay, so looking at the time on behalf of CEWEP and ESWET, I truly would like to thank all our speakers for their time and their precious contributions today. I also would like to thank all the participants for your interest in this webinar. Soon you will find all the presentations that we've seen today in the CEWEP and ESWET websites. And in case you've missed any part of the event, the recording will be also available soon on the ESWET YouTube channel. With this, thank you all again for your attention, and I wish you all a great continuation of your day. Bye-bye.
Thank you very much. Bye.